Alright guys, welcome to 6.1a, day 2 of Law of Sines. I'm just going to read through this first part. So far in Trig, we've only solved right triangles. More advanced Trig methods allow us to solve all triangles. One of them is called the Law of Sines. Now, we did this yesterday. We proof of our Law of Sines, draw a non-right triangle as follows. The Law of Sines told us that the sine of angle A divided by the length of A is equal to the sine of angle B divided by the length of B, or the sine of angle C is divided by the length of C. Today what we're going to talk about are the 6 cases when using law of sines. The first 4 involve acute triangles. The last 2 involve right or obtuse triangles. We use law of sines when we are given 2 angles and a side, always one triangle in this case, or when we are given one opposite angle and 2 sides. So SOAS. So this is side, opposite angle, side. When given SOAS, you must always think of the cases and whether you have one triangle, 2 triangles, or no triangles. For the first 4 cases, you must find the height first. Now, the height is going to depend on the orientation of your triangle. Obviously, if you have A and B at the bottom and C at the top, then this would apply, that the height is equal to the length of B times the sine of this angle right here. It would depend, though. We could also say it is the length of A times the sine of this angle right here. So 2 different ways to kind of approach that. Let's talk about case number 1 first. For case number 1, it says given an acute angle and the opposite side is smaller than the height. So case 1, they're telling us that angle A is 35 degrees, side B is 3, and side A is 1.5. So if we think about the actual triangle, I'm going to draw it like this, and then I'll draw just this part, and I'll leave that there. I'll call this A, because they're saying A and the side opposite. I'll say this is B, this is C up here, this is little b, this is A, and this is C. So I'm not going to continue A all the way down, and the reason I'm not is because we are testing to see whether or not we have 1, 2, or no triangles. And in example number 1, it's telling us this is 35 degrees. They're saying that little a is 1.5, and B is equal to 3. Now, how do we know if we have 1, none, or 2? Depends on our height calculation. We have to calculate the height because, in this case, we need to know if the height, which is right here, is it going to be longer or shorter than A? Now, if we think about it, just common sense, if you have a situation where your H is longer than your A, then what that tells you is that this thing right here could swing freely across here and never touch the base of the triangle, which means we would not have a triangle here. Hopefully that kind of makes sense. So that's kind of the goal here, is we have to test to see, can we even do this? And we do that by using the sine of A, because we know that angle measure, and the length of C. This one is H is equal to B sine of A. That's what this up here was telling us. So looking at this one, it's going to say B sine of 35 degrees. And when you put that in your calculator, you're going to get an approximate answer of 1.72. Well, then looking at that, that means then that if this is 1.72, well then in our situation here, A is less than H, which means no triangle. Hopefully that makes sense here. There's no way to make a triangle because the length of A is too short. It won't reach the base of the triangle. That's for the first problem. So case 1. Case 2, given an acute angle and the opposite side is equal to the height. So now they're saying that the opposite side A is equal to H. Well, if A is equal to H, then it should stand to reason that we would end up having one triangle, because the only place where A is going to touch is going to be right at that point right there where C is. So, same idea. Here's our triangle. And it's saying that B this time is 30 degrees. Oops, sorry. 30 degrees. It's saying that B is 3.5, and I'm going to make this A over here is 7. So if we think about this one, it's the same idea. We still have to have a height here, and this is our right angle. And looking at this particular one, then, we would use the same thing here. Now, keep in mind, now B is in this corner, and A is across from us. So to find the height for this one, it is the length of A times the sine of B. So it changes slightly from what this one said. Plugging those values in, we get 7 sine of 30 degrees. Let me go back up here. I forgot this shouldn't say B right here. This should have said 1.5. Sorry. Just notice that. So back down to here. Now we could take out our calculator, but hopefully you guys remember that the sine at 30 degrees is actually a half. And so half of 7 is 3.5. So now we're saying that B, or the side, I'm not going to say that. I'm going to say opposite of the angle I used is equal to the height, which means one right triangle. And that's what we would have for this one. Hopefully that makes sense. Those are the first two cases. So let's look at case number 3. Case number 3, it is saying given an acute angle, and then the opposite side is greater than the height and greater than the adjacent. So we're going to draw that same type of triangle, and we're going to label it. This one says now they're giving you angle C. I always just try to put that angle in the left corner. It makes it easier when you're drawing these things. The opposite side is 10. This one is B right here. They're giving us is 8. So that means this is B over here and this is A up here. And now we are going to drop our height. Here's H. And then we're going to calculate H. Now, H for this one, it's angle C, but it's side B. So this is B sine of angle C. That makes this 8 sine of 48 degrees. When you do the math for this particular one, you're going to find that your height value for this one, I'll have to do this one on my calculator. So this is going to be 8 sine of 48 degrees is 5.945. 5.945. So looking at this one, it's definitely showing us here that our angle measure, this one, is going to have, it's going to be longer than this one. So what does that mean in terms of our triangles? Well, it means this. It means that our opposite side is greater than our height, and the opposite side is greater than the adjacent side, because this one right here is our adjacent side. This is our opposite side. It said given an acute angle and the opposite side is greater than the height and greater than the adjacent side. So here was the first part, here was the second part. What we're going to find here is that we are going to have one triangle. That's the only way that this will work, is that you're going to have 1. And as you're going to see in just a minute or so, that we're going to have a situation where we will have 2 triangles. But this particular one, we can only get 1 triangle out of this. And it would be, if I extended this side, it would definitely make 1 triangle. Here it made 1 triangle, but it meant that this one right here was a right triangle. It made it a whole right triangle. So hopefully this makes sense. 1 triangle when the opposite side is greater than the height and the opposite side is greater than the adjacent side. Now, one other thing to point out to you guys. Drawing your triangle the same way every time, reorienting your A, B, and C, kind of gives you that idea. It kind of hopefully helps you to keep things straight. Those are our first 3 cases. Let's move on to case number 4. Case number 4, it says, given an acute angle and the opposite side is greater than the height but less than the adjacent side. So let's take a look at what we mean by that. Out here is my triangle, so I'm going to draw that right here. They're giving us these values. So they're saying for case 4, A, so A is in the corner at 56 degrees, side A is 5, and adjacent side is 6. So what does this mean for us? Well, we need to, first of all, calculate our height. So here's the height. We're going to calculate the height so that we can set this thing up in terms of opposite sides, because that's the important part here. So H is equal to, well, they're giving us angle A, and this was side B. So here's B right here, here's C. So this is little b sine A to find your height. This is going to be 5 sine of 56 degrees. When we do the math for that particular one, we're going to see that we have a length here of roughly 4.97. Now, given that we have that particular one, what is it that we're going to look for? Well, we're going to look for this height in relation to the opposite. So opposite, in this case, is going to be greater than the height. And if I look at that, the opposite is also less than the adjacent. When this is the case, when you have this situation, you will have 2 triangles. Now, why is it that you're going to have 2? Well, let's think about this. If this is my original triangle, then hopefully you see we would have 2, because the first one we would contain or continue on, and it would say A, and here's B, and here's C, and this one was 5, and this one was 6, and here was our height, which was less than this opposite one. So the opposite would swing down, but it would hit the base before it actually became parallel or right on top of the H. So it would have that one. But it would also have this triangle. It would have one that might look like this. So here's our height. It's in the same place. But now here's this, and we didn't change this angle at all. The angle measure is still going to be 56 degrees. Okay, so this is capable of creating another triangle here, because we can also link it up. If we go back to this one right here, if this is 10, well, if we swing this around and we swing this inward, this side of 10, if I keep swinging it across here, now 48 degrees is going to disappear, because once I pass this line, yes, we could put another one out here and say that, sorry, that looks ugly. We could put another one out here, and we could say that this right here would be 10, but now we don't have that angle. So I hope that makes sense there. That one, there's no possible way that we can create two triangles out of this. We can only create one. But here, I can link this up and still retain this 56-degree angle. And that's the key to this one, that there are two here. So anytime you have that situation, you're going to have two triangles. Hopefully the first four make sense. All right, one other thing that I did forget to mention. If we were solving these triangles, this would still be angle A. But now angle C is different, and we would call this C prime. Angle B is going to be different, and we would call this one C prime, or B prime, excuse me. Because now you have a different triangle here. You've got two triangles, and you're going to have to solve them. In a minute, we're going to come back, and we're actually going to solve... Actually, no, let's do it right now. We're going to solve these two triangles before we move on to this last part. For this one, we're going to solve, first we'll solve this triangle, so we'll do this one first, we'll do this one second. And when I say solve, I mean we're going to find all the lengths and all of the angle measures to these particular ones. So in the first one, I have two sides. I need to find this side, and I need to find this angle and that angle. So how do we do that? Well, we do it exactly how we would have done this. Now I know you don't have as much room as I do on this thing, so write it down the side, cram it in here. We'll separate that off from this next problem, which is going to be right here, so just separate it off from there. All right, here we go. So we are looking to solve for angle B, we need angle C, and we need length C. This is an approximation. This may also end up being an approximation, and the last angle would probably be approximation as well. So how do we solve this triangle out? Well, for this first one, we need length C. I have angle A and opposite, so I can say for the first one, sine of A is equal or over 5 is equal to, I'm just setting up the law of sines, so sine of B over 6. Or sorry, yeah, over 6. So now I'm going to solve for sine B. Well, that means multiply both sides by 6 and take the inverse. So B is going to equal, this is going to be the inverse sine of 6 times sine of A, which in this case is 56 degrees, and I'm going to divide that by 5. I'm going to put all of that in my calculator, and when I do that, I'm going to actually get an answer of 84.2 degrees. Angle C, we're going to do the same thing. This is going to be sine of A, which is 56 degrees, over 5. And we're going to have an angle measure here. Now, in order to find this one, I got to first do the work to find the angle. So I don't actually need to do that. I have two angles. I just need to find length C. I find angle C by saying angle C is equal to 180 minus, this is 56 degrees, plus the angle measure for B, which was 84, and now I'm saying 84.2, but you guys have to keep in mind that you shouldn't be rounding to one decimal place. You should be using the answer you got in your calculator as the value here. So even though I'm writing 84.2 degrees, you need to be very specific when you're rounding down to one decimal place. But it makes sense here that this one's just going to be 39.8 if you're going to round. Okay, but you should be using exact answers. So now, setting up my law of sines to find the length of C, I would have sine of 39.8 degrees, and I'm dividing that by the length of C. Well, then C for this problem, C is going to equal, this is going to be 5 sine of 39.8 degrees. All of that is over sine of 56 degrees. When you plug all that in your calculator, you're going to come up with an answer of approximately 3.9. So I have solved the first triangle. I solved it out. But I'm not done yet because I now need to solve the second triangle. A is going to be the same, but C, obviously now C prime is going to be a little bit shorter. B prime is going to be a little bit different, and C prime is going to be a little different. So I need to solve that out. How do I do that? Well, I still have A. I still have this one. Now I can sort of get an idea here of how to solve for B prime if we think about geometry and what we did in geometry. In geometry, we said the following. Here's what the triangle for that one originally looked like. Here was B. Well, we calculated B. We said B was 84.2%. 84.2 is not percent, but degrees. Well, that means then, hopefully you guys agree that this side is also 5, which makes this whole thing right here an isosceles triangle. This one right here, it is an isosceles. And what hopefully do we remember about an isosceles triangle? Well, it has the same base angles. 84.2 is also that one. So in order to find angle B prime, because that's one of the ones that I need, angle B prime, I can simply hopefully understand that this is really just 180 minus 84.2 degrees. Why? Because they are supplementary angles. So hopefully that makes sense. This is going to end up being approximately, for this first one, B prime, this is 95.8 degrees. So that one pretty straightforward, hopefully, to find. Angle C prime then, well, it's going to be 180 degrees minus the addition of 95.8 degrees plus 56 degrees. So approximately for angle C, we're going to get 39.8 degrees. So not terrible to find those first two because you're just taking the information you already hopefully recognize and know and applying it. Little c, how do I find little c? Well, little c, I've now got sides of angles that I can use. I know that little c up here is 39.8, and I already know A, and I know the side opposite A, so I can use the law of sines again. This says sine of A, which is 56 degrees, over 5, has got to equal the sine for this one, which is 39.8 degrees, over little c. One second. All right, I see my little error here. C prime, I think I said was 39.8, but I believe, and let me check this, and the only reason I'm noticing it is because the two seem to come out the same. So let me go 180 minus, this is 95.8 plus 56, 28.2. That makes more sense. So this one is 28.2, and this would be in degrees, which now changes my calculation here. This should say sine of 28.2 degrees, and I'm going to find C. So now this is not just C, but C prime. So C prime is going to be 5 sine of 28.2 degrees over the sine of 56 degrees. And then we're going to calculate that one out, and what we should find when we calculate it out is that our C prime for this particular one is approximately 2.8. This would be the solving of that triangle. So hopefully that makes sense in terms of how you would solve these. And this is something you have to be able to do. So hopefully you take time to kind of absorb that in terms of how that works, because you're going to be asked to do that quite a bit. All right, this last two parts. These last two cases, case 5 and case 6, are what we call the ambiguous cases. They are the ambiguous cases for law of sines. And it says for the first one, given a right or an obtuse angle and the opposite side is greater than the adjacent side. So we're already saying this is an obtuse triangle. So what does that mean? Well, my triangle is going to change slightly. When I go to draw this one, instead of drawing it the way I've been drawing it, I kind of want to draw it like this. I want to say, here's this one, here's this one, here is this one. Okay, and what we're saying is this is an obtuse angle right here, and it is 112 degrees. The side opposite of it is 23, and then I'm going to say this is B and this is C, and the side that's adjacent is 17. So hopefully we see that particular piece. Now, what does that mean in terms of our solving here? Well, if the opposite is greater than the adjacent side, and we know we have an obtuse or right angle, then we know that we are going to have one triangle. That will be the case. Okay, that's what they're saying in this particular problem. And once again, if you were going to solve this, you would need to work it out. You can use law of sines here. You've got an angle and a side opposite. You have a side opposite, you would find the first angle. Once you have that angle, you find your other angle. And then once you have the third angle, you find the third side. Okay, but this situation would give you one triangle. And then your very last one, case number 6, given a right or an obtuse angle and a side that is opposite, or sorry, and the opposite side is less than the adjacent side, what's going to happen? Well, hopefully this one makes pretty straightforward sense. If you have this situation, well, keep in mind, the bigger the angle, this one says 98 degrees, this says that the opposite side is 15 and that the adjacent, and it really doesn't matter which it is, but they're calling that C, so we'll call this C and this A as capitals. Well, it's going to make sense here. If you have basically the biggest angle and the side opposite is smaller than any of the other sides, then that means that you're going to have no triangle here. That just has to be the case. Hopefully that makes sense here. If you think about it as a right angle, then this would be the hypotenuse right here, 15, and that has to be the longest side. So hopefully this makes perfect sense when you guys are working this out. Those are basically our angle measures. Now it says for example 7, what do they want us to do? It just says to set it up. They said when given 2 angles and a side, you will always have one triangle. There are no cases to consider. Why is that? Well, if you're given 2 angles, you know 3. And so that basically tells you that you have a full triangle. Sidewise, it doesn't really matter which ones they're giving you. Here they're saying we have a 34-degree A angle. So let's just say something like this. The B angle is 62. So I'm going to say this is A, this is B, this will be C. And A right here is 34 degrees. B is 62 degrees. We'll define the last angle. Angle C is going to be 180 minus 34 and this, which is 96, which is going to be 84. So you're going to have 84 degrees right here. and this is an acute angle, and we know one side B is 7.12, and it says this is just because you are given two angles, you really know all three, so it makes no difference. Up here, you were only given one angle. Up here, one angle. For case number 3, you were given one angle. Case number 4, one angle. Case number 2 and case number 1, one angle. So if you're only given one angle, you've got cases to consider. But if you're given two angles, then there's always just going to be one triangle. Hopefully this makes sense. It didn't say to solve it, just said to set it up, so we were kind of getting that idea. This is one of those things you're just going to have to play around with a little bit. You're going to have to kind of think your way through it. I usually like to take the moment here. I know we're at 30 minutes, so I don't want to take too much longer, but I do want to just point something out, that if you have acute angles, so acute angle, you have 4 cases. 1, opposite side is less than the H. There's no triangle. Number 2, opposite side is equal to H. You have one right triangle. Case number 3, opposite side is greater than the height and greater than the adjacent. Well, then you're going to have one triangle. And case number 4, opposite side is greater than the height and less than the adjacent. You will have 2 triangles. Those are for acute angle that you're given. And the second part, I know that your page is going to be a little slim, so just find somewhere to do this. When you have obtuse angles, when you're given an obtuse angle, you have 2 cases. Number 5, which said that the opposite side to the angle you're given is greater than the adjacent. Then you are going to have one triangle. And number 6, opposite side is less than the adjacent. That makes no triangles. This is just a kind of a quick summary of this whole thing for you guys to have for your studying purposes and when you're trying to work out problems and you're trying to apply them. I hope this makes sense. If there's questions that you have, as usual, please bring them to class. Please ask them so that we can clear them up for you so that we can get ready for the work that you have to do. I hope that's all for you. We'll see you guys in class. Bye.